My name is Kevin Lewis, and this is the midterm technical presentation for software design and development. Digger enemy. As a digger enemy, I want to appear in a random horizontal and vertical position so that the player cannot predict my location. As a digger enemy, I want to stay within the walls of the level so that my attacks can damage the player. The game data class creates an instance of digger enemy and puts it on a random X and Y somewhere within the window to start. As the digger enemy goes through its states, hole opening, hole open, appeared, hole closing, and hole closed. Right at this point, the location is randomized again on the screen, so random X and random Y is given the location, and it starts over. So every time it pops back up, it is given a random location on the screen and in a random X and Y coordinate. As a digger enemy, I want to fire the second I'm done digging out of the ground so that I can have the best chance of damaging the player. As a digger enemy, I want to fire a single bullet so that I can begin the delay before digging into the ground. So if we look at the state chart here, the hole opens and the enemy comes out. Once the enemy and the hole are at their full size, the enemy does this. He creates a new digger shot, receives the reference for the digger shot, and then adds the digger shot onto the enemy figure's array list in game data. It does this once every time through its states, and it only fires a single, or puts a single bullet onto the array list each time. As a digger enemy, I want to fire my bullet towards the location of the player so that I can attempt to damage them. We use trigonometry for this, so this would be the distance between the digger shot and the player on the X and on the Y. This is the distance we want to actually move the digger shot each frame. This is the angle. If we take the tangent of the angle, it's this distance over this distance. The arc tangent of that over that gives us the angle. Then we can use that angle times by any speed number to determine how quickly we want to move the digger shot towards the player. As a digger enemy, I want to stay above the ground for 2 seconds so that the player has a chance to attack me. So after the hole opening, hole open, and into the appeared state, there's a variable for the frame count, which is initialized to 0 in that state, and the digger enemy does not start its change of states until after that frame gets to 80, and it's incremented each call to the state, and it's done at a rate of 40 frames per second. So 2 full seconds would be 80 frames, and then it starts its change to the hole closing state. As a digger enemy, I want to bury myself after each attack so that I can dig myself up in a different location. So, looking at the state diagram, we open the hole, we appear, we shoot the bullet, we close the hole, and then we randomize the location and start it over. So after each attack, we will open a new hole in a new location for another attack, unless we are damaged, which means the health has been depleted. And at that point, we will do the explosion animation, which is another thing I implemented. I used this sprite sheet right here for the explosions. It's 16 images. So we call load images function. Load images takes these images and places them into a list of buffered images called explode images. It's broken up by each individual image and placed as a new image in the list. And then we do this by explode images.add the sub image, which is this one. Then the main image is made the sub image based on how many frames you want to wait for each part of the image. So in mine, I wait 3 frames on each image for 16 images for a total of 48 frames for an explosion animation before the damage state is given the done state and the enemy's gone. Freezer enemy. As a freezer enemy, I want to move in the X position towards the player so I can get in range to freeze him. As a freezer enemy, I want to move in the Y position towards the player so I can get in range to freeze him. As a freezer enemy, I want to continue moving towards the player so that I can freeze him. Similar to the digger shot, the freezer enemy uses the same trigonometry to locate the player, but unlike the digger shot, the X position and Y position of the player are updated every frame, so he follows the player no matter where the player moves. This keeps him going in the right X position, Y position, and he always continues moving towards the player. As a freezer enemy, I want to freeze the player when I hit him so I can stop his motion. We can see with the secrets diagram what happens. Freezer enemy on every frame checks the pixel collision between the freezer and the shooter. This is a method I brought over from my OOP class, which does the following. You have a collision box around one image and a collision box around the second image using rectangles. However, we don't want this function to return true unless these two actual images are colliding. So every time these boxes collide, we go through every pixel on both images, and if that pixel is not clear in collision box, meaning it's not it's an actual part of the image, and it's also not clear in collision box 2, meaning that it's actual part of the image, that means that the actual images are overlapping pixel wise, then it returns true. So if it returns true, then the freezer enemy sets a frozen variable on the shooter to true. This variable stops the shooter from being able to move. Then after 80 frames, we set the variable back to false, which means the shooter can move again. As a freezer enemy, I want to move away from the player until he becomes unfrozen, so he cannot attack me. So if we look at the state diagram for the freezer, he goes to started and then down to freezing. Once he's in this freezing state, he does the same trigonometry as when he's chasing the player, except for he goes in the opposite direction, so dx and dy are negative, and this is updated every frame similarly, although the player can't move, so he only moves in a straight line away from the player based on the last direction he was going towards the player. As a freezer enemy, I want to move towards the player when he is unfrozen so that I can freeze him again. So once we get to this freezing state, similar to the digger enemy, there's a variable for counting frames. It's initialized to 0 once we hit this freezing state. The freezing state moves the freezer away from the shooter until the variable is above 80, and then also the shooter is unfrozen when the variable is above 80. This variable is incremented each call to the state, which is done at a rate of 40 frames per second. So 2 times 40 would be 80 total frames for 2 seconds, and after that 2 seconds, the player is free to move, and the freezer enemy will continue towards the player.